here from Emerson to talk to you about the remote test separator solution that you see behind us. This is my colleague.
Hi, I'm Otto Vikingstad.
And we're here to talk to you about some of the issues associated with today's traditional technology in the separation world. Typically what we hear from our customers as we canvass them around the world, if there are issues associated with the rather large footprint of a traditional test separator and a manual manifold that you would see typically behind me. What they tell us is that it's quite expensive as well as a weight constraint when they take this particular solution offshore. Another problem that we hear from our customers is associated with sanding and potential foaming of the test separator. Well, these are operational issues that our customers are looking to try to eliminate. And then finally, if you're the production engineer, there are issues associated with the latency of information that you receive. If you have your traditional manifold in manual, you need to send an individual out to that location to be able to move the test separator production line from line 1 to line 2, requiring a trip to the field and considerable amount of time before the production engineer is able to get useful information that allows him to manage his choke to optimize production and subsequently be able to produce more oil and gas. So, Otar, why don't you take us through what we have behind us?
Right. So what you see here is a multi-port flow selector. It basically takes up to 7 different wells coming in to these inlets and combining the commingled flow on this outlet. In addition, we're able to select any one of the inlet wells going through this valve selector and then onto the test outlet on the bottom. And that feeds onwards to a multi-phase flow meter, which is a very compact solution that basically does the same job as the test separator and even more. The whole arrangement is electrically controlled, connects electrically with all the communication, and the multi-port flow selector is electrically controlled as well.
Good. So some of the benefits that we're able to achieve with this unique solution is a dramatically smaller footprint, significant weight savings, the ability to remotely actuate the manifold, as you see behind me, in the form of this valve, and be able to give the reservoir engineer more timely information that he needs to be able to control his choke and subsequently increase the overall production rate while not damaging his well.
In this case, where we have 7 wells tying into here, we would save 14 isolation valves and all the piping required for a conventional manifold. And in addition, the whole operation, the whole well testing can be done remotely, like in the case of an unmanned platform, rather than having to have people fly over with a helicopter once every day to do all the testing, all the valves, everything, to do the well testing on a conventional test separator. This solution allows operators to do all the well testing remotely from a control room on a nearby platform. That basically summarizes the solution that we wanted to explain to you today. Thank you for listening. Larry, do you have anything to add?
Yeah, you can certainly see this solution if you query emerson.com and look for reservoir management or, in this case, the remote well test optimization.